Hello everyone, today I'm talking about linear algebra again. I want to highlight that what's the difference between the algebra and linear algebra. Mainly, it's about the vector. Vector, right? Our main concept, making the things simple, right? Simple. So, how it's going through? Initially, we start a simple basic two equation with two unknown. Then we are trying to imagine that 100 equation with 100 unknown. Could you solve right now? Most probably not. Even could not imagine right now. Don't worry, we will. Okay. Let's write our main equation: 2x plus y equal to 3 and x plus y equal to 2, right? Okay, that's a simple equation. You can solve directly. But let's understand. How could I make simple this equation? How could I this two line with a one line? Initially, I initially introduce you to a vector. These cool things means that that's a vector. Has a meaning in the space. You can draw, you can imagine. It's just fascinating, right? Brilliant. Okay, how could I fill it now? How? I'm looking at the coefficient of the x. It's a 2. I write it. I'm looking at the coefficients of the y. It's a 1, right? Let's write it down. I'm looking at the coefficient of x again in the second line. That's a 1. I'm going to get the coefficient of y in the second line. That's a y2. And this is called coefficient vector. Can you figure out? Coefficient matrix, I'm sorry. It's called coefficient matrix. That's a cool name, right? Matrix. Okay. When I'm writing a coefficient matrix, what is my main point? I am looking at the unknown vector, unknown variable, right? That's a x and y. So can I describe this in a vector in space? Yes, of course. Yes, I am. That's x and y, respectively, isn't it? Let's write it down. And y. And we got a result. This result has to be meaning in the space. We can draw it directly. And so I can show this also in a vector notation like this. So that's a coefficient matrix. That's the unknown vector. Unknown, I hope I write it correct. Unknown vector. That is also result. I call this result. But we had a really cool way to say it. This is a really form of a x equal to b. What is a? A means that there's a coefficient matrix, right? Okay. Unknown vector means that x. We call always x is an unknown, right? We call it again, make it simple, make it in a one line. You can write this in a one line, right? X, and that's a b. But is these things help me to solve the equation right now? Is this to make easy? Is this to make simple? In 20 equation maybe, but in 2 equation not. And even in the 20 equation, I prefer you to split this coefficient matrix into two parts. First part is 2, 1, column 1, and second part is 1, 1, right? And as you can see, 2, 1 is a unknown variable of x, and 1, 1 unknown variable of y coefficients, right? So I can write it. Let's make it x 2, 1 plus y 1, 1 equal to 3, 2. After that, that is really simple to do, simple to going through, because I give a number instead of x and y. I try to add them up. I forget this. I try to add them up and find the 3. Try to find the 2. respectively. I'm looking at the first part, is it this part, and I'm looking at the second part, like mathematical conversion, like adding them up, like putting instead of x 1 and y and 1. So I'm looking at again 2 plus 1 equal to 3. Give me the result. I like a puzzle. That's a funny things, right? And 1 times 1 plus 1 times 1 equal to 2. Oh, that's giving me 2. So I figure out that if I put the, instead of that, if I am looking at the 4 to 5, let's presume, not like this. 5 to 3. Let's figure out that I should put the x equal to 2 and y equal to 1. And this gives me the 2 plus 2 times 2 plus 1 times 1 equal to 5. And 1 times 2 plus 1 times 1 give the 3, right? That's all meaningful to us. But what does that mean? Does this equation fill the whole space? Or did I draw something in the space to understand these columns? No. Let's try to figure out these meanings in the space and how could I draw them up directly. Let's write the first example and going through with them. What is that? Yeah. Okay. 3, 2. Before passing through the drawing process, I would like to introduce to you. If I write, that's a 2. Let's write 1, 1, 1, 1. This means that in 3 space, this encounter the x-axis. This encounter the y-axis. This encounter the z-axis. This is the 4. That's we cannot imagine right now, but we can draw. But that's hard. Okay, pass that. That x, that y, that z. So if I am going back to my case is 2 and 1. 2 and 1. That's the first part, x. That's the first part, y. And the rest of that is drawing vector. Drawing vector in xy plane, right? So let's draw it. Okay. That's the 2, that's the 1. Let's getting there. That's the column 1, right? And there's a 1 and 1. That's the column 2. And adding them actually give to me. Let's make it long to us. And adding them directly give to me 1 is the result. So B. Just adding vector, right? I put them, using the parallel style. And I draw it directly. And this gives me the third vector, so B. Actually, I love this logic. Because it's like a solving puzzle, right? So it gave to me, I putting x equal to 1, y equal to 1, and getting the result. I putting x equal to 2, y equal to 1, I'm getting the result. Or not, I put this number, looking at the answer, is it suitable or not? If not, that's not correct guess. But the most important thing, after finding this, what does that mean? Should this give a point? Should give a plane? Can I fill the whole space with them? This is the main question of the linear algebra. Is this equation exist? In our case, yes, exists. Is this equation fill the space? Actually, we don't have now in 3-dimensional space, but we got a 2-dimension. It's definitely fill. How could I do that? I'm looking at the tangent function. I'm looking at the slope. That's a 2, that's a 1, that's a 5 divided by 3. None of them is on each other. If I got some function and them on each other, I couldn't